All right. Good afternoon, everyone. And yeah, maybe in Fiji it's afternoon and morning in China. And my name is Jason, and I'm the SuperMap International Asia and Oceania Technical Manager. And today I'm going to share with you about the new modes of smart city development, which is digital twin city. So first, let's discuss about what is digital twin. I got this definition from, I got this concept from the Wikipedia. So a digital twin is a virtual representation that serves as a real-time digital counterpart of physical objects or progress. And in the urban planning and the construction industry, the geographic digital twins have been popularized in urban planning practice, given the increasing appetite for digital technology in the smart city movement. These digital twins are often proposed in the form of interactive platforms to capture and display real-time 3D and 4D spatial data in order to model urban environments and the data feeds within them. So from the concept, we can see in the urban planning and the construction industry, the digital twin can be divided into 3 steps or 3 phases. The first step is modeling. And today I'm going to introduce you 2 types of new 3D model, which will be very helpful in the smart city construction or digital twin city construction. And the second phase is visualization. We can visualize the model in different platforms, such as in 3D GIS platform or in VR or in AR. That is very helpful, very necessary to show the model in different platform, different terminal. And the last one is management application. It includes the planning, design, construction, and O&M. O&M means operation and maintenance. So today, my presentation also can be divided into these 3 parts or 3 steps. The first one is modeling, then visualization, and management application. So this is the outline of this presentation. The first 2, oblique photography and beam, we talk about the modeling, and then we discuss about the management application, and the last one I will show you some cases. So the first important data model or data format is oblique photography. Oblique photography technology is a new high-tech technology developed in the international mapping and remote sensing industry. Oblique photography captures images from orthogonal and 4 oblique directions through multiple sensors placed on a flying platform. We can see this is the camera in the UAV. We always use this kind of camera to take picture for one object from different angle, from different direction. And then we can see for this building, we can have multiple pictures from different direction for it, such as from the top, from left, from right, from, and after that, this is the step of data acquisition. And after that, we can use some automatic modeling process in the softwares to generate the oblique photography, like from data acquisition to the aerial triangle measurement encryption, and then go to point cloud, then TIN and DSM. And the last one, we paste to the texture to DSM, we can get the 3D modeling. There is one example to show the oblique photography in one city. And you can see this is a big city in China, and there are a lot of high buildings. We use UAV to fly around this area, and we can see the model looks very real, and and each costs a few time and manpower. So there are 4 advantages of oblique photography modeling, which are high efficiency, high realism, high accuracy, and low production cost. So the oblique photography is it is a very important model format in the smart city construction or digital twin city construction. And in order to use it, we have to do some management function based on the oblique photography model. But the oblique photography model has the same feature with the satellite image, which are the models are continuous with each other. For example, the building is continuous; it is connected with the road beside of it. So in order to make them independent, we can have we need to do some methods to extract the building or extract the object from oblique photography. So yeah, here what you can see is the way we can do it, which is we can overlay the vector polygon with the oblique photography, and we store all of the attributes for the objects into the vector polygon. And then every time when the user choose the objects in the oblique photography, we can get the attributes from the vector in order to get the attributes for the model. And this one is the dynamic singulation, such as we can draw the polygon and overlay it with a building in the model, then import some message. We can manage the attributes of this building. And so based on it, we can also render the different color for buildings to create the thematic map like this. And also we can do achieve the management of 3D real estate for urban complex building. And next, I want to talk about the BIM. BIM is Building Information Modeling, and this is a definition by American National BIM Standards Association. And the digital expression, it is a digital expression of a construction project. And also it is a shared resource, provides a reliable basis for all decisions during the entire life cycle of the facility from construction to removal. So in different stage of the project, different roles insert, extract, update, and modify information in BIM to support and reflect their respective responsibilities in the collaborative work. So the BIM developed a lot over the world in recent years, such as in US, in Korea, in China, and also in a lot of other countries. But today we are going to discuss, our focus is not BIM itself, but we will focus on the integration between BIM and GIS, which is between the building information modeling and geographic information system. So the GIS informs BIM and BIM fuels GIS. As I mentioned earlier, the BIM need to cover the whole life cycle of a building from construction to removal, or maybe from design to removal. So the BIM software can play an important role in design, plan, and construction stage, but the GIS can help a lot in the operation and maintenance and query analysis or data management stage of a building. So that means from macro to macro and from outside to inside. So about the management application, here I also want to divide them into 4 steps. The first one is input and visualization. And then we will talk about planning and then analysis and simulation. And the last one is maintenance and sustainability. So in the management part, the first one is input and and visualization data. So for the oblique photography, there are a lot of automated modeling software, such as Street Factory, Context Capture, Photo Scan, Pix4D, and others. So for this kind of oblique photography in SuperMap in this GIS platform, we can easily to integrate them into GIS. And what we are seeing now in this picture, this is a very beautiful building on the side of a mountain, and we use UAV to generate the oblique photography and import it to SuperMap iDesktop. We can see the building is very detailed and very beautiful. And another one to show the capability of visualization of oblique photography is this one. This is one of the city, and it covers more than 600 square kilometers. And the oblique photography data reaches 3.2 terabytes. So in this way, we can show the capability of visualization of oblique photography in GIS platform. And in talking about industrial chain of oblique photography, the SuperMap plays, which is means the GIS platform, only play one part of each inside of the industrial chain, which is first we need to use aircraft or oblique camera to fly, and then to catch the pictures in different angle and automated modeling. And after that, we can use GIS platform to do the visualization and management of those data. And based on the GIS platform, we can establish a lot of different types of industry applications. And the next is about BIM. The BIM also has its own softwares, such as Revit, Bentley, CATIA, and it also has some formats such as CTGML or IFC. So for all of those common used software and formats in BIM industry, SuperMap iDesktop or SuperMap GIS platform can easily integrate all of them, such as we can see the model in Revit and corresponding model in iDesktop, the model in Bentley, and model in iDesktop, model in CATIA, and in iDesktop. So they can all keep the same between GIS and BIM software. And then after we import and visualize all the model, including oblique photography and BIM, the next step is planning and design. So there are some problems, such as I want to achieve the collaborative design, or ground and underground planning, multiple planning, conflicts, and scientific planning. So there are some applications can be done or can be achieved in this stage, such as online design, parametric design, 3D design, model browse, internal room, and scheme comparison. Let's take a look at some of the functions. First, we can create the platform, which is 3D geographic design cloud platform. And this is one of real system we made in Hong Kong. And we can see the base map or the surrounding environment, they are all oblique photography. But in the center, this is the important building we use BIM. So the first function I want to show you is scheme compare. We at the same location, we can upload the different model, then we can easily to compare them. And also we can compare the differences in the street view and in the differences in the photos, in the photo montage. So in this way, we can easily to compare different schemes in urban planning. And another one is planning approval, which is we can when the designer uploads their model to the scene, then the user or the worker can check the model floor by floor, and they can do some analysis, such as to do the measurement, to do some other spatial analysis to define whether this building is okay or not. So this is about the planning approval. And next is parametric design. That is, in one area, we can easily to add some blocks in based on some template. Then just to add the parameter in different way, then we can easily to establish a building or to add a building model in the specific area. Okay, and in the urban planning area, there are also some other functions, such as there is a rule which is setback. The setback means the building line refers to the boundary line that controls the buildings along the street. Any building or structure adjacent to the street shall not exceed the rule line. So in the urban planning area, we can set the setback line, and we can set the setback along the street to analyze which building exceeds this line, and that means this building is illegal. And there are some other analyses, such as 3D design, which is we can based on it to analyze the openings. This is the openings analysis. And also we can do the shadow analysis. use some points to we can simulate the location of sunshine, and next is the float analysis. We can simulate the float in the city. And the slope and aspect analysis based on the terrain data. We can see the color is more red, means the slope is more high. And also the free drawing and skyline analysis to analyze the differences, the differences between skyline and like between add a new building. Okay, there are more cases in smart city, such as in planning modeling, in decision support, and design monitoring. Next, we go to next stage, which is analysis and simulation. So in this stage, there are a lot of analysis functions, such as the cross clipping, which means we can draw a box, draw a transparent box, and we can easily to see the inside of the building of the model. And it also supports the spatial query and attribute query. And at the same time, it supports to modify or manage the attributes for every object in the building. So this is based on the building information modeling. And besides of which, other functions also can be provided, like 3D spatial relationship judgment, such as query objects based on query conditions. It can be contained, separate, conceit, intersect, be included, or related. And a lot of other spatial analysis based on GPU can be provided, like viewsheet analysis, shadow analysis, extract skyline, section map, terrain contour map, terrain slope aspect map. And all of those the result of those analyses can be exported, or they can be saved as a solid model, and in order to do the further analysis. The last part of management and analysis is maintenance and sustainability. it can solve some problems like incomplete supervision with and insufficient safety monitoring, weak early warning and emergency scheme, and poor management facilities. There are some functions like video supervision, emergency management, asset management, equipment management, safety management, and indoor navigation. For example, we did one project for a skyscraper maintenance management, which is the Shanghai Center, which it is the second tallest building in the world. And for this building, we mainly achieve the maintenance function, such as the parts control, and we can easily to modify the information of objects. And we can do the parts query and position, which means based on some conditions, we can locate the model in the building. And for the viewpoint management, that means we can have some viewpoints, we can save them, and the next time when we want to come back it later, then we can click the viewpoint and come back it directly. And the video supervision means the building can integrate with the CCTV camera, and we can simulate the area of camera. And when we click on it, we can see the real-time camera video in the system. And emergency management means we can load some emergency plan to simulate the emergency, such as this one is a fire, and the car come from the fire station to do the scheme. Okay, and next is asset management, which means for every object in the building, we can manage the attributes of it. We can get all of the information, all of the attributes of every object in the BIM building. And it also has the mobile application, which so it can provide the function like problem report. So when we do the maintenance or do the check manually, we can use our mobile to report the problem to the system directly. And in the system backend, the administrator can easily get all of the information of this building. Okay, the last one, there are some cases. First, this is about first is a career. This is a BIM management system, and it has some functions like video surveillance, labor supervision, environment and monitoring, carrier of all sensor information, and progress supervision, the video conference, and equipment monitoring. All of them can be achieved in the BIM management system. And next is the Shanghai Center, which is a very tall building. The total BIM data size is reached to 252 gigabytes, and the number of 3D model of this building reached to 3 million. So we can see the function of it, like the equipment check, facility maintenance, park energy consumption analysis and optimization, and security facilities integration. In the BIM operation platform, we can also achieve the model show or query, browse model properties, emergency simulation, and spacing tool. All of the system also can be shown in a big dashboard or a big screen. And there are some other applications like building overview, key area display, the building management, weak power management, fire warning, or video management. All right, so these are all of the presentation, the content of my presentation. Thank you for your time. Then maybe next is Qin.
Good afternoon, everyone. This is Qin speaking. I'm a technical support engineer in SuperMap Asia and Oceania Center. Today, I'm going to have a presentation about SuperMap solution for mobile surveying and 3D cadastre. For cadastral management, we know that the most important thing is to get cadastral data. The data can be from paper map, CAD data, as well as surveying. So at the beginning, I'd like to talk about how to get data through SuperMap template, which is a mobile app developed by SuperMap mobile. So now let's take a look at the first section, mobile surveying. Firstly, let's have a look why it is necessary to do surveying. Even we have paper map or CAD data, but we always need to verify whether there is any change or not. So we need to assess and update it. Then we should think about how to collect the data, how to manage the collected data, as well as how to finish the collection work. So firstly, we may want a device for data collection. We may consider that how to synchronize the data, or you want to work offline or online, as well as how to connect data efficiently. And then with the device, you may want an easy way to use it. It should be easy to connect data. It can support take photos or edit data conveniently. In addition, it is also a key point about how to synchronize the data from surveying works or synchronize surveying results to the office so that we can modify or update data in time. So here we have SuperMap template that can meet the above requirements. It is a mobile app without development requirement, and also it is a industry-wide surveying and mapping tool. So let's take a look at what can SuperMap template do. There are 9 main functions of SuperMap template, including mapping, or surveying, or navigation, or data analysis, and others. And also at the same time, it is convenient for you to share the data from the template to others through the SuperMap online. So you can easily upload your collected data from a template to your colleagues, and also you can easily get the collected data and operate and process the data in the desktop terminal. And here, there are all features of a template. Just as I mentioned, there are main 9 functions, but what's more, we can do more about it since we also provide custom development, so you can customize your template for better work in your field. And then let's take a look at the first function. It is data collection. The data collection tool provides many methods for you to connect the data. You can draw the points or draw polygons, and as well as draw lines. And also you can connect the data by GPS or by tracking. And at the same time, you can take photos and they upload the photos to the template. And also we provide many process tools which you can edit the collected data easily. Here, let's take a look at the workflow for data production. With SuperMap template, we provide a complete workflow from the data collection to data processing to data analysis and application. So you can create or customize a template for better to use the template to connect the data. And after that, you can directly edit the data, just like you can union or you can dig the element and also edit and also copy the data through a template. After that, we also provide the analysis tools for you. Later, I will introduce it. So SuperMap template also provides the high performance map operations. So you can view the connected results on your mobile with high performance. And there are many advantages of field serving, so you don't worry about there is not enough memory and there is not enough power. So the SuperMap template has the features of memory saving, power saving, mobile data service saving, and it is high efficiency and searchable and dynamic interaction. All this make it possible for you to connect the data in the field. And the next one is about mapping. And after you have the data in the template, you can directly mapping on the mobile, so you don't need to upload the data to the desktop terminal and mapping using desktop terminal. So if you want to get a map immediately, and then you can use the template mapping function, and there it also provides many styles and semantic map for you to make a beautiful maps. And then there is about the data analysis. You know that the data analysis is one of the important features of GIS. So with SuperMap template, you can directly do the spatial analysis on the mobile terminal. Just like the flood analysis and the buffer and the network analysis, you can most of the GIS spatial analysis can be achieved on the mobile on the SuperMap template, and with these distributed data analysis, you can also do the big data analysis, just like the density analysis and aggregation analysis on the mobile terminal. So you can view the big data, results on the mobile terminal in the real time. And as a mobile application, the template can also provide navigation. SuperMap template can not only provide the 2D navigation, but also the indoor and outdoor integrated navigation, as well as you see here, the 2D integrated with 3D navigation. And with AR technology, we integrated with AR technology. So here we have many AR functions, which just like we can view the AR, view the models through AR, and also do the AR survey. You can use AR survey to measure the distance or the area or the height of an object, and also we support the AR analysis. Here, let's take a look at the example. This is to display the beam data through AR. And you can see the buildings with real size. Then you can walk into the buildings. And also with AR technology, we can connect data with tracking. So it is easy for you to get the indoor data. As I mentioned we also have the AR survey function, just like you can measure the width and the length of object, and also you can measure the diameter of a tree, and also the height of a tree. And also measure the area of damaged road. So it is easier for you to do the measurement without the ruler. And I mentioned that the iTemplate can share the data to other colleagues. When the iTemplate supports the cooperation work, so after you connect the data, you can share the results with other colleagues. So also the data can be managed in one database at the same time. And also it can be displayed on the different terminals. And the next is about the customizing development. We provide the full functions, but also you can customize the functions which can make your application more easily. So just like you can customize the startup page, you can put your logos and your company's name, and also you can customize the homepage. You can also only keep the functions you want to keep in the template, and also you can customize the data management. And the SuperMap templates can be used to many fields, and such as the marine monitoring, national census project, POI survey project, also immigration project, also the land survey project. Any field which has the mobile requirements can be used with SuperMap template. So it is widely used. And then let's go to the second section, the 3D cadastre. While we are going to construct a 3D cadastre system, here we can see there are some reasons, just like the population growth and the existing land supply imbalance, so which requires us to better manage our land use, and also the intensive use of space above and below land parcels, and the legal status on utilization of space. And also the difficulties to reflect the spatial aspect of rights in 2D cadastral registration systems. And it is and also we need to check the value of a property become higher and higher. And also the development of the street technology makes this impossible to construct a 3D cadastre. And you know that in the real world, there are not only apartment buildings or shopping center, but on the ground, and also there are many facilities, just like the pipelines and the pipelines on the ground or underground, the pipelines indoors, and also all these these objects make makes the how to say it, sorry, I think all these features make us think about how to integrate these features into one picture. So here we are going to need this 3D technology to solve these problems. So here we list some of the technologies we required to solve these issues. Just like we should update the 2D data as well as build the 3D models for buildings, and also connect the attributes with 2D and 3D data, so we can manage the cadastre more convenient, and also we can achieve the information querying. And also it's better to unify the standard for cadastral data. So after we construct this system, we can access the new cadastral data in the future and manage different kinds of data easily. And after the system constructed, we can we can also and some analysis for the cadastral data, and also for the city planning, just like the legality checking, and also public information sharing. So we can integrate all this information into one system. And then SuperMap also provides the complete workflow of 3D cadastral management. The first step is the data management, including the business data and spatial data. You don't need to worry the different data cannot be managed by one system. With SuperMap, it can easily manage the spatial data and the non-spatial data. And after that, SuperMap also provide the tools for digitalization. So no matter you have the paper map or CD data or others, you can easily access to a desktop our product. And after that, we can also access the 3D models into SuperMap products, just like the oblique photography, photogrammetry modeling, also the architecture modeling, and the other models, later, I will introduce the models we support in our product, and after that, we can achieve the visualization of the result. So here, let's take a look at the data management. The SuperMap SDX makes it possible to manage the business data and the spatial data into one system. No matter you have the file data, or your data is in the database, or SuperMap can access all many kinds of data, just like the TIFF data, the shape file, and the PNG, and the Excel, and also we can access the Oracle SQL Server and the MySQL and other databases. So you don't worry about the data management. And we also support many formats of spatial data, including the vector data, just like the shape file data, and the DWG, the CD data, and others, and also the image data, the TIFF, the image, and others, and the models. We also the models with this formats can also be well supported with SuperMap at desktop. So after you import the data to the desktop, and then we can, if you have the vector data or the cadastre, if you have the cadastre vector data, you can directly import it into a desktop. But if you don't have it, you also don't need to worry about it. For the paper map or the CD data, we also support they are all supported to import it to the desktop, and then we provide the cadastre vectorization tools for you, which help you easily to do the digitalization, so you can get the digital cadastre quickly. Just like this video shows, firstly we can create data sets to store the rooms, feature, the doors, the windows, or the walls. Firstly, we can draw the rooms on the image, and then we can draw the contour of the house. So after that, we can use the wall clip to quickly get the wall data set. With this tool, we can get the wall wall quickly, like this. So So as for the doors, windows, and others. And also we can copy the walls to different floors and also edit the attributes. So here after that we can get the whole building's wall structure. And then we can quickly build the 3D cadastre. We set the elevation of each floor. So here we can get the 2D cadastre vectorization result, and at the same time we can construct the 3D model. And then after the vectorization, as I mentioned, it is necessary to construct a 3D system. So here, the first way is that we can firstly vectorize we vectorize the data to get the 2D data. After that, we can get the 3D model. And the second, we can also directly use the oblique photography. As in the previous presentation, Jason has introduced the oblique photography. So also the oblique photography can also used for a 3D cadastre. We can either need to get the bottom surface of the oblique photography, and then stretch this surface, so we can get we can quickly get 3D models. Besides, I just mentioned that we can also stretch the 2D data to the 3D models. So let's continue to view this video. It shows that the 2D and the 3D integrated viewing in the desktop, which we can check the information of each floor, and we can also edit the attributes of each yeah. So here we can, after that, we can check the information of each floor. And then we can also match the stretching buildings with oblique photography. So we can also achieve the proper pairing. And also there are many other models can be integrated together, just like the 3D models integrated with TIN, and also the 3D model merges with oblique photography, and also the 3D model merges with water. And also we support to access the video to these 3D models. So you can monitor, just like here, we can monitor the traffic in real time. And SuperMap also provides rich 3D symbols such as the trees, the street lights, the pipelines, and others, so which can make this scene much more beautiful and in real. And also here is the dynamic water surface symbol. This is made by SuperMap at desktop. You can view the water effect. And also, SuperMap has the unified formats S3M, which can manage different kinds of model data into one system. So all these different kinds of models can be output to one standard format S3M. Then these different kinds of models can be integrated in one system easily. So after that, we can publish the things you made, and then display your result in the multiple terminals. Just like you can construct the 3D images through WebGL to view it on the website. And also the 3D WebGL supports multiple functions, just like the clip, measure, 3D analysis, and the 3D editing and others. And also the 3D scenes can be displayed on the mobile terminal, and as well as the 3D analysis. So here, after we construct this system, we can add more functions, just like we can add the querying function to query the information of the buildings, and also we can and the legality checking to check the height to do the height control analysis. This is very useful in the design stage. So you can know which buildings meets your design requirements, as well as a legal distance detection. I think Jason had already talked about this. So and also this is also to build the 3D legality rules box to control the design. And then here are many cases of cadastre, and this is one case in Finland, and this cadastre system mainly use the oblique photography as the base data, and so it achieves the cadastre management through this system. And also this is another case in Netherlands. This system integrates for oblique photography with 3D models. Here, just like you see the bridges, and then you can see the pipelines underground. So this is a more complex system to manage the city's cadastral information. And also we can build the smart community to manage the cadastral information of our community. And here are some 3D cadastres in China, which after you create, here you can query the household information and also the householder and the family's information, and also you can check the house diagrams information, and also it provides the statistical analysis which can achieve the house feature statistic and the house types statistic and the usage of the house statistic. as well as we can construct this system is constructed by the vectorization and 3D modeling. Here, no matter which type, it can, or they all can convenient to manage the cadastral information and the household information. So I think that's all of my presentation. Thank you. If you have any question, please feel free to ask. Thank you.